Hello everyone, welcome back. So let's get to doing some examples. Oh, there we go. So example 1. Ooh, we got a fancy little problem here with the picture. So given, the operator applies a vertical force to the pedal, right here, so that the spring is stretched 1.5 inches, right here. And the force in the short link at B is 20 pounds. What it wants us is to draw an idealized model and free body diagram of the foot pedal. It's not even asking us to solve it. Yes! Okay, so this is pretty simple. And maybe pretty hard. As a note, like free body diagram drawing is an art. There are some companies which will ask you on the interview, like just draw a free body diagram of a paperclip. I think that's Boeing. It might be Boeing or one of the other companies, but that was their interview question. Just draw a free body diagram. So before you take this to, like, well, I got this, focus, because there is so much that you can draw here and so much that you can learn. Okay. So we look at it. First off, we have to draw a nice idealized model. We take our picture, it transforms into an idealized model. We give all of our dimensions, which are necessary. We also have to define what that spring constant is going to be, because that's going to turn into a force. We idealize our supports. Obviously, there's no like nice little vertical or angled plane with this pin. You can see there's a pin right here, but we can't really see how its pin is held in place. We just know it is held in place. And we have another distance right here. We add in any unknown forces, which is this force F. Okay, so here's our idealized model, and now we cut. So we cut right here, we cut right here, we cut right here. We replace those with forces. So we said our total was 20 pounds right here. I said it was 20 pounds per inch for our spring constant, and we know that force is equal to the spring constant times the change in distance, which will be 1.5 inches. So 20 times 1.5, that's 30 pounds. We cut our support, and so we have to replace it. It was a pin support, as we can see from the picture. And because it's a pin support, we will have a reaction force in the X and the Y directions. And then finally, we have our unknown force here. Now, you might be wondering, well, can I solve this? Is it actually possible to solve? We'll count the unknowns. 1, 2, 3. You most definitely could solve this. It's not impossible. In fact, it's actually a fairly simple problem. If all you're caring about is force F, you actually only need one equation to do that. You could just do some moments around A, and both of these would disappear. You could solve for F. So most of these problems are much more simple than you'd think. But it takes practice. If you don't see the easy solution, just go at it. Start writing equations you will solve, because there's 3 equations, 3 unknown. You might just have more algebra than you necessarily needed. Okay, let's try example 2. And this I'm actually going to solve it. Actually, let's just make us draw it. We'll do the group problems to solve. Okay, so right here we have a platform. You can see it's being held by 2 wires up here, and it has a mass of 200 kilograms. I'm going to draw an idealized model and a free body diagram. So let's go ahead and do that together. First off, idealized model. Typically you're trying to draw it in a 2D form if it's symmetric. If it's not symmetric, don't draw it like this. You have to make it 3-dimensional. And so I have a rope holding it up. I have a pin support on the large tower. And I also have to take into account the fact that this, this platform has its own center of gravity. It has weight, and that weight is going to be pulling at the center of this usually. In this case, though, it's not a symmetric shape. You can see there's extra material right here, and so it's off-center. But it gave us all the distances. So we have all of our dimensions. We've drawn this as nice as we can, showing all of our support types at each point, all the angles we need, and now we cut it and replace with forces. So the rope becomes a tension. The pin support becomes a reaction force. And we finally apply the weight at the center of gravity. And we can solve this. In fact, let's just go ahead and do that. Here, I'm going to solve for the tension and just show you how I can do that. So I want to get this tension right here. And this is one of those things where if you really are looking at it and paying attention, you can solve these just in a snap of fingers. Well, to do this, I want to get rid of as many unknowns as possible. And I remember that if I take the sum of the moments around a point, all the forces that apply on that point, or have their line of action going through that point, don't apply to that moment. So, if I do the sum of the moments around A, what I get is 1,962, and that'll be times 1.4, so that's how far away it is. And then I'm going to subtract from that t, but I only want the vertical component of t because it's a horizontal distance. And that would be, let's see, that would be cosine of 20, just because I want to use cosine. That'll be times 2.2. And then I'm also going to have a second component from the horizontal component of this force because there's also a vertical distance there. So minus t, and that would be sine of 20 times 1 equals 0. Okay, so as you can see, I could solve for t with one equation. Also, if I did some of the forces in the y direction, it's actually another equation where I can solve with just one unknown. Because I only have, actually no, I have two unknowns there. Sorry, that was me going to out of line. Once I solve for t, I could solve for the force in the y direction. I could solve for this one. Once I solve for that, I can solve for this. It really just makes it easier if you do it in the right order. But no matter what, you will still get there. Okay. Now, I'll let you plug this into your calculator if you want, because I don't have it actually typed out yet. And you can check my work and see if I did it right. If I messed up, email me. Let me know. Okay, but next time we're going to go into some harder problems where I actually draw these free body diagrams and then solve them. So, look forward to that. I'll see you all next time. Bye-bye.